We're going to look at how to add or subtract two rational expressions. Remember always that to do arithmetic with rational expressions is to follow the same strategy as would be used for rational numbers. So if we want to know how to add or subtract two rational expressions, we should first remember how to add or subtract fractions. And when adding or subtracting fractions, the most crucial step in the process is the step in which we bring both fractions to have a common denominator. This is a step that is vital to the process of addition or subtraction for fractions, but which is unnecessary for multiplication and division of fractions. So finding a common denominator is a skill that we generally only bring into play when we're doing addition or subtraction. The same is going to be true here when we add or subtract a pair of rational expressions. We cannot do so until we first have brought both fractions, both rational expressions, to have a common denominator. Once we've found a common denominator, we can then add or subtract across the numerator, leaving the denominator the same, and then simplify whatever rational expression that we get. Because we're working with rational expressions, though, the first thing that we should always do is to factor everything in sight. Factor every numerator, factor every denominator. In the example on the screen right now, there's actually not much work to do. We can't factor x minus 1, we can't factor x plus 2, or x, or 2, in any way that's meaningful. So instead of factoring, I'm just going to surround each of those with a set of parentheses, just to remind myself that x minus 1 goes together with itself, x plus 2 goes together with itself. And that's important at the next step, and this is the step that is just as important when working with rational expressions as it was when working with fractions. And that is that we need to find a common denominator for this pair of rational expressions. Just as with rational numbers, the low-hanging fruit, if you will, the path of least resistance often, to find a common denominator is simply to multiply the two denominators that you were given. In this example, that will give me a common denominator which is the product of x minus 1 times x plus 2. I generally recommend that if you aren't comfortable finding a least common multiple for a pair of algebraic expressions, that this way, just finding the product, which is a multiple of the denominators, is the way that you can go that requires the least amount of thought up front. If there is another option, this method might give us a little bit more work to simplify at the end of the problem, but that work is typically a little more straightforward than trying to find a least common denominator at this stage in the process. So I recommend just using the product of the two denominators always. So now we know what our common denominator will be, x minus 1 times x plus 2. So let's rewrite both fractions having that as its denominator. Our next task is then to figure out how the numerators should change to adapt to this change in denominator. After all, for example, my first fraction, x over x minus 1, evidently its denominator has been multiplied by x plus 2. And if I multiply the denominator of a fraction by something, I must also, in order to preserve the value of that fraction, multiply the numerator by the same quantity. So to so-called balance the numerators, what I need to do is multiply each of the numerators by whatever is necessary to have multiplied it by the same quantity by which the denominator was multiplied. If I have used the product of my two denominators as a common denominator, in other words, if I have multiplied straight across right here, which we have, then the quick way to balance the numerators so that they adapt in the appropriate way is to use the cross products. In other words, the numerator of my first fraction will be the numerator of my original first fraction, x, multiplied by the denominator of my original second fraction, x plus 2. So x times the quantity x plus 2 will be the numerator of my new first fraction. Likewise, for the second fraction, its numerator will be the product of the original numerator of the second fraction with the original denominator of the first. The reason, again, is that in order to go from a denominator of x plus 2 to our common denominator, we have multiplied by exactly the quantity x minus 1, which is the denominator of the first fraction. So if I multiplied by it in the denominator, I also must multiply by it in the numerator, giving me a new numerator of 2 times the quantity x minus 1. This is probably the trickiest step in the process of adding or subtracting rational expressions. So it's worth your time to look back at what was done right here and make sure that you're comfortable with this process, because this is the step, I believe, where it's easiest to commit small errors that will lead to an incorrect answer down the line. Once our denominators are common, just as with adding and subtracting rational numbers, we can carry out the addition or subtraction by carrying it out just in the numerator. So I will subtract x times the quantity x plus 2 minus 2 times the quantity x minus 1, and that difference will be my new numerator. Meanwhile, my denominators remain the same. So never add or subtract denominators. Just keep them what they were when you found the common denominator. So we've now succeeded at turning our two fractions, which are being subtracted, into a single fraction, a single rational expression, x times quantity x minus 2 minus 2 times quantity x minus 1, all divided by the product of x minus 1 with x plus 2. So as always, our last job, now that we're down to a single rational expression, is to reduce it into its lowest terms, to see if there are any opportunities to cancel common factors. The problem is that because the numerator now is a difference, it has more than one term. It has a one term x times quantity x minus 2 and a second term 2 times quantity x minus 1. It's not apparent what the factors of that numerator are. So before we can simplify, we should simplify the numerator and try to refactor it if possible. So here is the one place in working with rational expressions where I recommend using the distributive property, using FOIL, multiplying things back out, instead of keeping them factored. Ultimately, we're going to try to refactor it, but before we can do that, we do need to multiply it back out. Doing so gives me a numerator of x squared minus 2x minus 2x plus 2. Denominator remains the same. I can combine the like terms, minus 2x into minus 4x. And now my numerator has been completely simplified. But we still can't tell whether there is a common factor between the numerator and denominator, because what we're seeing in the numerator are not factors, but terms. Now 3 of them, x squared minus 4x plus 2. So we have addition and subtraction upstairs, not multiplication. So we can't see if there's anything to cancel yet. So what we need to do is to try to refactor the numerator. We would do that with the sum and product rule, because we have a quadratic trinomial, and look for a pair of numbers which multiply together to give me 2, and which add together to give me negative 4. Well, you can try as hard as you like, but you're not going to find a pair of numbers that have that property. So this particular numerator does not factor in any meaningful way. Because it doesn't factor in any meaningful way, when we look for common factors to cancel, we're not going to find any. The numerator is not divisible by x minus 1. It does not have x minus 1 as a factor. It also is not divisible by x plus 2. It doesn't have x plus 2 as a factor. So, regardless, there are going to be no common factors that we will be able to cancel from the numerator and denominator of this expression. And so this expression is already in its lowest terms. So that was a lot of steps, but that's characteristic of the process of adding or subtracting two rational expressions. Firstly, factoring everything in sight, which is something that's especially important down the line when it comes time to simplifying a fraction into its lowest terms. But crucially, just as with adding and subtracting rational numbers, the top priority after factoring is to find a common denominator which can be used to bring both fractions onto the same footing. The most straightforward way to do that is to simply multiply the two original denominators, as was done here. If you do multiply the two original denominators to get a common denominator, you can then balance the numerators using the cross product, the numerator of one original fraction multiplied by the denominator of the other. Then the actual addition and subtraction happens by adding or subtracting the numerators and keeping the denominator the same. Finally, to simplify that fraction into lowest terms typically involves the one time in working with rational expressions when multiplying things back out might help. So multiply everything back out and attempt to refactor it. If that's possible and there's a common factor, then that common factor can be reduced. If it's not possible, as it wasn't here, then at that point your rational expression is already in its simplest form.